Good morning, thank you. First, I want to thank CIMCO and the team that put this together, afforded me the ability to come and speak to you. I'm an application sales engineer for a product called Arid-Dry. We also market under Arid-Ice, which is our product that we sell to ice arenas. We're a dehumidification company. We specialize in drying air and drying facilities. Why do you need to dehumidify? How many people have seen their building look like this on the left? It's not a good experience for your customers. It increases your operation cost, and we can solve those problems. It's all about the moisture. The environment outside your building often can be much higher moisture levels than what you want to experience inside your building. And that moisture can cause you all kinds of problems. One of the bigger ones is condensation, which can lead to mold. Black mold can be a real problem for your facility and can actually shut you down in some instances. This condensation also can cause problems at your ice surface, because often in these facilities you'll have structural steel members that cross over the top of the ice. The condensation forms on those members, drips down on your ice, and you end up with mushrooms. And you can also get rust spots, because that's generally steel above there, and it rusts, corrodes, and then drips down on your ice. There's also a component of concern regarding that in terms of the corrosion that can lead to a structural integrity problem for your facility over time if that's allowed to just continue without being addressed. Boards fog over the ice, soft and poor ice conditions. These all take away from your customer's experience in your facility. So where does this water come from? Well, there's a multitude of sources from where this moisture comes from. I'll touch on a few of them. One of the most common ones is anywhere you can see light, moisture can get into your building. So keeping your door seals, keeping your penetrations well gasketed and sealed with caulk, whatever other sealant material you want to use, is very important to help mitigate moisture infiltration. Door openings. Every time a person opens a door and walks into your building, there's an air exchange that occurs right at the door from an uncontrolled space to what hopefully is a controlled space. And that's a load. Your ZAM or resurfacer room, every time the 10 by 10 roll-up door opens, there's again an exchange between an uncontrolled and a controlled space. You're bringing moisture into your facility. That's an operational concern that you can actually address by just telling your operators to minimize the amount of time that door is open. Don't leave it open the whole time you're out there resurfacing. Shut it behind you while you're resurfacing and then reopen it, because that can significantly reduce that load. Your people. For every person that's just sitting in the stands idly, not moving, just watching the event that's going on, they're giving off about 1,000 grains per hour of moisture just by breathing and by perspirating. An active skater on the floor will give off about 7 times that amount of moisture. So this is an example, 15,000 people, that's a large facility, probably larger than most people in the room are operating. That would represent about 282 gallons of water an hour that's being introduced into your building. So imagine 282 milk jugs. Now, if you scale that down to something that you're probably more dealing with, 1,500, that'd be 28 gallons. That's still a large amount of water being introduced into your facility. Believe it or not, even though your building may have a solid wall, there's actually permeance that's going on through the material. Depending on what it is, moisture can actually migrate right through a solid material. It moves on vapor pressure differential, and that's a very powerful force. The material depends on how much permeance occurs. Steel doesn't have very much permeance, but concrete has a very high permeance. So be aware that your building itself is allowing moisture in. The 600-pound gorilla that we generally deal with in terms of moisture is your ventilation demand. It's going to be by far your biggest concern about where moisture is coming from. For every 1,000 CFM of outside air that you bring into your building, on a summer day, you're bringing in as much as 6 gallons of moisture an hour. Very significant. And we have to ventilate in these facilities. It's mandated. I don't know, what code you follow, but generally engineers and inspectors follow a code laid down by ASHRAE. It's the 62.1 ventilation code. Its most recent rev is the 2013 version. And what that code says is that you need to bring in 0.18 CFM per square foot of play surface, so that's your ice sheet. That works out to about 2,700 CFM. Or if we think about what that means in terms of moisture content, that's about 18 gallons of water per hour coming in. For each person that's in the building, each spectator sitting in the stands, you got to bring in 7.5 CFM per person. So if we went to that large facility example again, that would work out to about 733 gallons, or if we scaled it down to 1,500, it'd be 73 gallons per hour of moisture. A lot of moisture. So how dry is dry enough? Where do we need to suppress the dew point to in your facility to get rid of all those problems and to save you money? Well, in theory, you'd want to control to a dew point that's equal to or less than the lowest surface temperature in your facility, and that's going to be your ice sheet. Generally, that runs somewhere between 15 degrees F and 25 degrees F. So for this case, we said, oh, 20 degrees sounds like a good place to be. Well, in practice, after years of employing this technology and working with it, we discovered that about a 35-degree dew point is good enough. You don't need to go quite that low. And the NHL actually has come to a standard that agrees with that. That letter that I just showed you couldn't read, so I'm moving on, was actually sent out to all NHL facilities in 2000 that were going to be in the playoffs. And they've set this standard, and I believe they're still following this for playoff mandated standards. And what it says is that they need to control their facility to 60 to 65 degree F and no higher than 40% relative humidity. And they need to achieve that condition within 3 hours prior to the game and hold it throughout the entire game. That's what the NHL requires of these facilities. And the only way they can do that is to actively dehumidify the facility. So what technologies can we use to achieve those levels? Well, there's a couple of approaches. One that's not quite as effective. It can do some level of dehumidification for you. And it's called a cool reheat system. It's simply a cooling coil. You run your air across the coil. It wrings out the moisture because it's cooling it down. It condenses on the coil, goes down the drain pan, and that's your dehumidifier. The downside or the detriment to that system is about the best dew point you can achieve off of it is around a 40-degree dew point, and maybe 38, maybe 45. You know, it's all over the range, but somewhere around 40 degrees. The reason you can only achieve that dew point is because if you suppress the coil temperature lower than what you would get for a 40-degree dew point, which is probably like a 35-degree coil, maybe 33-degree coil at the lowest, if you suppress it lower than that, you're going to start to freeze the moisture on the coil. Now you've stopped dehumidifying, you stop working. You can try to implement defrost cycles, multiple coils with dampers and all these other systems. I've never seen one that works really well down below 40-degree dew point. So if we said that we needed to achieve a 35-degree dew point to get rid of all of those problems, and we're delivering 40-degree dew point as a control, we're never going to get to set point. So that building we can really only reasonably expect to hold maybe 50, 55-degree dew point, which is higher than what we said is going to be acceptable for you and your customers, and it's going to negatively impact your operating costs. So the technology that we employ is a dry desiccant technology. It's a rotor, basically. It's a substrate that we corrugate, and we impregnate a desiccant material, in this case aluminum silicate, into this material. Because it's fluted, the air can pass through it, as you can see. And the desiccant in that material is what's actually dehumidifying for you. That aluminum silicate can retain about 40% of its dry weight in water. So the air passes through the wheel, either return from the facility or maybe a combination of return and makeup. The moisture that's in the air is given up to that aluminum silicate in the substrate. The air comes out dry. Now, there is a finite capacity to this desiccant. Eventually, it'll stop working once it equalizes with whatever the moisture content of the air is. So we have to regenerate it. Whoop, back up. And what we do with air is we take a heat source, which I think it's going to show up over here in a minute. We heat up to about 250 to 280 degrees. The air is then passed through the rotor in a counterflow direction. The moisture that was absorbed in process is now given up to this warm air, and we can reject that away from our control environment. And in this way, the rotor is continuously regenerated, and the process is a continuous process. Now, with this technology, we can achieve, now this is a pretty typical return condition from an ice arena, 65 degrees, 30 grains, that's 35-degree dew point. We can achieve pretty readily 0 to 10 degree F dew points coming off of these wheels. So much lower dew points delivered to the space allow us to get much better control of the humidity within the space, and we certainly can achieve 35 with no problem. This is actually from a case study, and it's from this larger facility, but we can scale it down to show you savings in your facility. We had a facility, it was actually a college facility in the US that had just mechanical cool reheat systems. They weren't happy, they weren't satisfied, they were having problems throughout the year. And we looked at what the loads were, and after we derated the tonnage, the amount of cooling that it required, it was 100,000 CFM that they were cooling. After we derated it for all the losses, it was actual tonnage of about 770 tons is what was required to not quite make set point, because they were only getting that 40-degree dew point. And then they also had to reheat that air, because if you're getting a 40-degree dew point, you have to cool the air down to 40 degrees to get there, and you don't want a 40-degree environment in your rink. So they had to reheat so it was something comfortable for the spectators and the skaters. We went in and we applied desiccant technology, and we took all of the outside air load, which is that largest component of load, and we ran it through a dehumidifier, and then we fed that existing system. And when we combined the two technologies, what we discovered is the actual tonnage went down to 540 tons from the 769, 770 tons that they originally had. That represents an electrical saving of about 800 kilowatts per hour. Significant energy reduction. Now the desiccant does have to be reactivated, so we're adding energy that needs to be accounted for, but it was nearly a wash with what they were using for reheat energy. So those kind of counterbalanced out. They still needed to apply energy to reheat. We need energy for reactivation. So their actual savings was this number right here. Again, you can scale that down. For a 1,500 seat arena or something in that name, it'd probably be a 70-ton saving or something like that. But there's definitely savings to be had. So without control in your facility, one of the biggest operational costs that is impacted is your ice sheet. If you don't have a dehumidifier, if you don't have humidity control in your environment, that moisture goes to the lowest surface temperature in the space, that's your ice sheet, and that becomes a partial dehumidifier. That load, which is a latent load, which is a high load, is translated back to your ice plant, and it increases your operating cost. So if we control the environment so that we're not having that moisture painting out on the top of your ice surface, your ice quality goes up, and your operating costs go down, and you let your ice plant do what it's good at, and that's make good quality ice, not remove moisture. This is a system that we released this product 4 or 5 years ago. We built it for CIMCO. It was originally designed to be a replacement system for CIMCO's Humicon, which is a cool reheat packaged small dehumidifier that goes in the corners. It can also replace Hussmann, Dectron, Desert, any of those cool reheat systems. We designed it. It's an electric system, uses PTC electric elements. It's a low-grade energy, and we did that intentionally because we wanted it to fit the energy profile of what that existing mechanical cool heat system would have, so that we could be roughly the same power consumption, so you don't have to bring a new power service over there if you're retrofitting one of these in for your mechanicals. We also designed it to be very similar in dimensional and weight, so that it could fit on the same stand without very low modification costs to you, the end user. It's designed for smaller facilities, recreational facilities, curling rinks. It doesn't have a lot of capacity if you're dealing with large outside air loads. You'd have to look at one of our other technologies for that. But it works really well in these smaller facilities, or as a replacement to a worn-out mechanical system. I'm not sure if you can read this, and I apologize. I can provide this information for you later. But this is basically, it's a capacity comparison between a mechanical system. In this case, I used a Hussmann product, and the MS-2600. The highlighted yellow areas are your typical ice arena operating conditions. And if you plot the points, you're going to see that in most cases you're going to have 2, 3, and in some cases 4 times the capacity in the MS-2600 product that you would have in a mechanical system for the same amount of power consumption. So that translates to you reduced operating costs. If you have 4 times the capacity and equal energy, you have 4 times the savings. It also translates to reduced operating costs at your ice sheet, as I mentioned earlier. If you keep the humidity under control, it means your ice plant's going to be more efficient, more effective, and cost you less to operate. Improves the environment for your customers. What you are selling is an experience to your customers. If they come in and there's fog and condensation, there's dripping and it's raining in there, they may not stay, and that's a detriment to you. Mold and corrosion, huge concerns. Black mold, if you get it in your facility, if it's bad enough, you may have to bring an abatement company in to remove it. They come in, they abate the mold, and then it's got to be certified that it's been fully abated. And the whole time, your facility is not allowed to be occupied, so you're losing dollars and you're spending money. The corrosion control I touched on earlier, even wood facilities that are allowed to be wet for long periods of time, it leads to corrosion of that material, which can degrade the structural integrity. And I've actually know of a couple of cases in the US where they had roofs collapse as a result. R22 phase out, this is another strong reason why you'd want to buy an MS2600 product. By law, R22 is being phased out and is required to be removed from your facility. A lot of the older mechanical systems prior to maybe 2000 or 2000, I don't know when the actual drop date was, but they're going to be an R22 based system, and they really need to be out of your facility to be in compliance with that. This system uses no refrigerant, so it's a very good replacement for that. And I guess I'd say don't take my word for this. This is some testimonials that the CIMCO team actually provided for me, that these are customers that has bought the product in the past few years. Randy says that the air and ice quality are both at a recognizable difference, and this is showing a great difference in our compressor runtime being down from last year. So he's seeing energy savings as a result of employing this technology. Paul, prior to the installation of these new dehumidifiers, we came in each morning to sweating glass, wet floors, and lumps all over the ice. Once the desiccants were in place, the difference was amazing. So he's seeing an improvement in his experience and his quality. Sue Smith, once the desiccants were in place, the difference was amazing. I would be very comfortable recommending this to anyone looking for a new dehumidifier, especially if, like us, you're putting in ice in hot, humid conditions. Greg Storms, since the installation of our new units, we have not had to cancel a ball hockey game, or our ice has been fantastic. We now have excellent air quality, no bumps, no wet glass, and a better environment for players and spectators. So I'd say, in general, the experience has been very good. So if your mechanical system fails, or if you need to phase it out, we can drop in a 2600 very low cost, both in terms of upfront cost and your installation costs. And you can actually phase it in if you have existing systems, you can phase it in over years so you can keep the budget, something that's more manageable. This is just a little touch on, and this is in the buying process when you're doing this. You need to know that this system was designed as a retrofit, so it's a little bit underpowered in terms of capacity because we're trying to stay in that power profile of the reheat system. So in that buying process, take that into account. Don't think that if I buy one of these, it's going to solve my problems, because it may not. It will improve your situation, but if you don't apply it correctly, and that's where CIMCO can help you and make sure you're applying enough of these units to make sense for your facility year-round. If you look at a typical single sheet, the load on a summer day is about 48 pounds per hour. This is a minimal seating, maybe 100, 150 spectators. Your MS2600 each will remove about 19 pounds per hour each. So if you had two of them, you'd be cutting it kind of close, and you might have 5-10% of the year where you're still not quite making it. Maybe you need to buy a third unit if you want to have a 100% solution.
I just wanted to let everyone know I had a great time at CIMCO Innovation 15. It was very beneficial, I think, for the arena operators and also as a supplier to be able to go ahead and enjoy the company of like companies, and basically very happy with the outcome of the event.